Yes, class. Good evening, all. My voice is audible to all of you.
Yes, ma'am.
Okay. We have completed both the formula, average value of AC for full cycle and average value of AC for half cycle. I hope you all have revised and come. Yes, Khadija, let's start with you. What was the formula of average value of current for half cycle? Khadija, you tell me for half cycle, and Sidra, you tell me for full cycle. Yeah. Okay, Khadija, half cycle. At least look into your notes also. For you tell me for half cycle, yeah, Khadija. Even if you do not remember, you can look into your notes and answer. At least you'll remember the formula by this. And meanwhile, Sidra, you were present in the last class? Yes, Sidra, were you present in the last class? Okay. Repeat the question. Sidra, average value of AC for full cycle, whatever is the heading. What is the value of average value of alternating current? Tell me the formula of alternating current, Sidra. That's the question. Yes, Khadija.
Do I not
2 by divided
by
by
pi?
pi. Correct. And exactly the same formula is for EMF. Correct. Very good, Khadija. Sidra, can you answer for full cycle now? Okay, Zaina, you answer. Sidra, it means you have not made the notes. If you couldn't even read your notes and answer. All of you open the cameras. All of you. With this liberty, nobody then answers. Very few students are there who are active in the class. Yes, Sidra and all of you, please open the cameras and then answer and then sit in the class. If you cannot, then you can leave the class. Yes, Zaina, do you remember average value of AC for full cycle? Yes, Zaina. Zaina, you were also absent. Zaina, are you able to hear or not? At least Sidra was responding that she was present or not. Yeah, you answer.
Ma'am, average value of AC for full cycle?
Yeah.
0, ma'am.
0. It's 0. That was the exact difference. Sufyan, you tell me what's the difference between AC and DC? Alternating current and direct current. Yes, Sufyan. Difference between Sufyan, unmute yourself. Basic difference, whatever I've told in the class, not a heavy definition. DC has a constant current over time. Good. See, over time you have to mention. Just constant current won't help. DC has a direct current, has a constant value of current over time. Means your time can increase, but direct current value will not change. In alternating current, with the increment in time, you will be getting different values of current. Okay, good, Sufyan. DC flows in single direction. That is also very good, Sidra. And you have alternating current flowing in flowing sinusoidally. Good, Citra. Okay, class. Then few more things were left here. RMS current we didn't do. Let us do this RMS current derivation. This is also very important. And again, all of you, please revise at least the basic formula. I do not ask very detailed questions in the class. And I have instructed something to all of you to open the videos also, except Yahya. Nobody has followed it. Please take 5 or 10 more minutes to arrange yourself or settle yourself, and please open the camera. Okay, so RMS value of current or effective current or virtual current all have the same term. So RMS current is the current which is used of RMS value of current. This is often used. So we'll be, when we are studying about RMS current, it's virtual current is rarely used. You will find RMS current. What is exactly this RM? See, R, M, S. R stands for root. M stands for mean. And S stands for square. Okay, root means square current. You have velocities also like this in class 11. So, your kinetic theory you must have heard of. VRMS means square, root means square speed. And so RMS means root means square. See, it is written as RMS, but the order is different. First, you take out the square. How? First, you take out the square means I, so I square. That is the first step. Remember it like this, you will be able to derive it on yourself. Second step, mean. Mean means average. So I square dt over time. Okay. And this is also from 0 to t. Since we are talking about a whole big current term, not just a single current, and this is alternating current. So you know your current will fluctuate with time. So we cannot take that formula of average current. That I1 plus I2 plus I3 plus I4 divided by 5 and that average value. No, we cannot take that. I square dt by t. This only we have to take here. Okay, I square dt over t. This is the value of what? This is the value of the root. Now class, last portion that is left here is the root. So I square dt over t, this we have already calculated. This is what we have calculated as the time. Okay, so I square dt means your current is varying with respect to time. And this t is signifying the value of the total current which is getting divided. So square and mean that. Last step is root. Last step root means that's it. You will put an under root in the last. So whatever question you will get, this is how you have to solve. Okay. Now you can further solve it. You can derive this. That's a different thing. But this formula, remember this formula because you will be getting questions directly from this. Okay. So IRMS is what? IRMS is you are integrating basically integral of I square dt t over time. Now class, when you are writing this, let's just solve this part. Only this part first. I square dt. Why am I saying solve this part only from 0 to t? If you solve everything within the bracket, and if you're solving everything within the bracket, not bracket, sorry, within this root sign, it will be really complicated for you. It will be a little messy for you to handle. Root is also going in hand. This in the denominator t is also going in hand. You will forget one variable. One constant will be left. First listen all of you, then you can write. So we are just solving this I square dt, this one. Okay. So you know I square, what is I? I naught sine omega t. In current, in alternating current, we always start with this I naught sine omega t. Because we know that current is varying sinusoidally. And we also know this fact that what? Current is varying sinusoidally with time. Okay. So that's why when you write this as I naught square, when you are writing this as I naught square and sine square omega. This is your I square. Okay, dt is there and your integral from 0 to t is there. In the last class only, I have told you how to solve the integral. Differentiation we have done, integration was there. So this also, see, I naught square is a constant. Bring this out. Straight away bring this out. 1 minus cos square omega t, not 1. When you have the square term, the way in differentiation, this actually, see, who have maths, they'll be discussing this in detail. For those who do not have maths and you just have to deal it in physics, just remember, it will become 2 omega t because here the power of sine is looking 2. Okay. So 1 minus cos 2 omega t, and what did I tell you? Whatever is the power, this will become. If nothing is mentioned, then omega will come in again. That is good. Then dt from 0 to clear. See, those who know maths, I know they are understanding this step, but those who do not have maths, for them, just understand. 1 minus cos omega t, I have already told you, divided by omega. When the power is there, like you have sine square, so this power 2 which is present, this becomes cos 2 omega t, and in the denominator also we divide it. So let's bring this 2 out with this. So this becomes I naught square by 2, right? Upper limit is capital T. So T minus what all we can bring. Or let us simplify this first. Let us simplify this first. There is an identity which we can apply and it can be simplified because it's a derivation. That's why I'm using the identity. In the normal numericals, you will not get such a numerical where you have to apply tough identity. For the derivation, see, some things are set that you have to write this only. Right? That's why few identities for the derivation part that you can remember. See, I naught square by 2, I'm taking it aside. This dt, when it will go here, it will become t. Correct? Dt, integral of dt is what? T. And when you are writing this becomes sine because we are integrating. We have just put the value, right? Now what we are doing? We are multiplying dt with this. We are multiplying dt. So what will it be? Sine 2 omega t divided by according to the identity. Okay. So you are integrating it from 0 to 2. This step is a little tough. So it's better, see, mathematics student must be understanding this, but non-mathematics, and 2 will also come divided by 2. For those who are having this confusion, for those who are having this doubt, I will suggest you just learn this step, learn it as an identity. Okay, because the entire derivation, you will not be able to understand at this moment. So this becomes I naught square by 2, capital T minus 1 by 2 omega, and from here sine 2 omega t is left. How we are integrating from 0 to, okay, this is actually dt, rather we will say this is dt. So this will become I naught square by 2 t minus c. T minus 1 by 2 omega is left, and c, sine omega is 2 pi by t. So 2 pi into 2 becomes 4 pi by t. Now this value is from 0 to capital T. Capital T is the total time. Now this is a little easier from, see, this step was only tough. From here it's easy to understand. It's easier in this step. Look, what were we integrating? From 0 to t, we were actually integrating I square dt. Let's see what it is equal to. Or let me remove this. See, this is I naught square by 2, capital T minus 1 by 2 omega. All these things are there. Sine 4 pi, first capital T will be put, upper limit. So we'll be left with sine 4 pi only. See, instead of small t, first the upper limit comes. So sine 4 pi by t, it's like sine 4 pi by t, and first upper limit comes. So what it is equal to sine 4 pi. We study AC every day after the class or whenever we have the class, and also every day, not just only after the class, because it is a little tricky at some points. It's a short chapter when we will be studying the individual circuits, AC circuit having only capacitor, only resistor. That time it is a little easier. But these initial derivations are a little tough to understand, especially students who do not have maths. So for you, it's a little difficult, and it's actually not. See, these derivations do not have any application. So even if you're not able to understand, at least write all these in your exam. In your CBSE final exam, just write it. You will score. Because wherever the users are there, that time I'll be going and jumping into the mathematics portion. Right now, you don't need to understand this in detail. Just understand, see, sine 4 pi, this is now the simplest part. You can solve this. See, what is sine 0? Sine 4 pi minus sine 0, it's 0. And see, when you multiply this term, this is getting multiplied to 0. 1 by 2 pi is getting multiplied to 0. So you're again getting 0. So what we are left with? We were integrating from 0 to 2I square dt. What are we left with? Just I naught square, this t by 2. Rest everything is 0. So that's why all these derivations are not very tough. If you see, these derivations are not very tough. It's just at 1 or 2 steps. You have to remember some identities for trigonometry. That will be helpful. So at least revise trigonometry, because you have done it in your class 10th, class 11th has gone. For those who do not have math. For those who have math, for them this derivation is easy. They'll be able to relate it. Integration, differentiation, they have done tougher version of this. IRMS, yes. Now IRMS, this is just this portion, I square dt. What was this the formula of IRMS? No. What was the formula of IRMS? We divided by t, the I square dt, integrating from 0 to t, divided by t also, and under root also. That was the formula. We have just solved this part. Means this has been solved. This t is left, this under root is left. T cancelled. I naught square by 2. So this is simply I naught, and this will be root 2. That exactly is the formula which you have to solve. IRMS is equal to I naught divided by root 2. And similarly, ERMS, same derivation for ERMS. ERMS is equal to E naught by root 2. What is E naught? Yes, yeah. What is E naught? In the form, in the derivation, what we are doing. In the last class, I have introduced you to this I naught, E naught. I told you what is the value of this I naught. Then we started with it. Turn the pages, look, you must have written it. Anybody who can answer? Anyone else? Very good, Sufyan. Maximum value of EMF. This is the peak value class. Peak value of current is this. That is the amplitude which we see. E naught is again the peak value or the maximum value. That divided by root 2 will give you the. So these are very important formulas. These two are both of these are very important formula. Okay. Write it down. Then I think straight away we have the question. Right. See class, how do you solve these kinds of questions? Firstly, write down the equation. E is equal to 140 sine 300 t. Now in AC especially, you have to relate whether you've got it relevant to the main equation. See, what's your main equation? Your main equation E is equal to E naught sine omega t. See, E naught is this. Omega is this. Means two things are mentioned in the question without directly saying it. So, E naught's value is 140 and omega's value is 300. Now, what is the first question? Peak value of the voltage. Yes, class. Answer. What is the peak value of the voltage? Do we need to even calculate it now? No. Peak value of the current is simply, voltage is simply 140 volt. So the answer for the first part, this will be 140 volt. This is 140 volt. Okay. Second is its RMS value. Okay. Now RMS value, if you know the peak value, see this is the peak value, E naught. If you know E naught, you can calculate RMS value. E naught by by root 2 is equal to E RMS. So E RMS is equal to 140 by root 2. You can put the value of root 2, 1.4 something. So see, approximately it will be 100. Approximately, please calculate the precise value. Last is frequency. Now we do not know how to calculate frequency, but one thing we know that omega is given. Omega is 300. So class, omega is equal to 2 pi nu. This is your linear frequency. Okay, this is linear frequency. So 2 pi nu is equal to 300. So from here, you have to find out the value of frequency. Frequency will be 300 by 2 pi, which is equal to 150 by pi hertz. This is the answer. This is how you have to solve these questions. Write it. Any doubts? Clear?
Yes, ma'am.
Others, Khadija, Mariam, Sidra, Sufyan,
Yes,
Zaina, clear? Write it. Okay, class. The next topic is phasors. Now, understanding of phasors is very important, class. Please pay attention, all of you. This portion is very important, phasors. See, what are phasors exactly? Phasors are just representation of the quantities which we have studied, like current and voltage. So see, every time it is difficult to tell you or tell someone that how much is the difference between current and voltage, at what angles are the current and voltage is changing. So phasor diagram, by just looking at the phasor diagram, you'll be able to relate. Yes, current is ahead, voltage is lagging behind. The angle between current and voltage is this. See, ultimately you have to draw the AC waves, the alternating current waves. Do you get this? See, you have to draw the alternating current waves. Alternating current wave means what? The sinusoidal waves. Yes or no, class? You have to draw the sinusoidal waves. So when you are drawing the sinusoidal wave, see here, class, understand this properly. This is very important for you to know. Phasors are basically rotating vectors. Now you have current in your circuits, you have voltage in your circuits. You have to show sometimes the position of current or voltage. See, graphs are drawn like this. Sinusoidal graphs are drawn like this. Agreed. But sometimes it's not necessary that current is also going like this only and voltage is also going like this. It can happen that your current is going like this in cos angle, cos theta, and then your sine curve is going like this. So there is a difference between them. There can be another case where your, let's say, voltage is going like this and your current is going like this, opposite of this. This can also happen. This can also happen. And it's not necessary that they're always separated. So whether it's the first case or it's the second case or it's the third case, in all these three cases, how will you represent? Every time you cannot write that current is lagging behind the voltage, as we can see, like in this is, see, you can clearly see here the difference is 90 degree. Right here, you can clearly see that the difference is 90 degree. If you see the difference here is 90 degree, then you can easily relate to the fact here that when we are saying this is 90 degree, what is happening? The difference between the values of the currents is changing. Current and voltage is changing. So you have to then write and then explain everything that yes, current has started earlier, then the voltage has started. So the graph of current is cosine and the graph of EMF is sine graph, sinusoidal graph, and this is the gapping between them, and this is the angle difference between them. So in order to avoid all these, and whether it's the first case or it's your second case or it's your third case, whichever case it is out of all these, best method is to represent them as phasors. So phasors are basically like your vectors. Like your vector means, see, vectors are a whole different quantity. That's a different, the entire theory of vectors were different. You all have studied vectors, correct? You all have studied vectors and you know that vectors have full, everything is different. The calculation of vectors are different. The formula of vectors are different. Vectors are dealt differently. You know this part. That if I tell you two quantities are there, if I say this is current and these are electric fields. So when you have to add electric fields, won't you be a little alert? You will be a little alert because you know electric fields are vector quantities. They cannot be just solved like this randomly. Okay, when we say electric fields are vector quantities, it means proper directions now have to be kept in mind. Proper angle has to be taken. So because they are vectors. But if I say you have to add charges, what you will do? What will you do? Positive charges, so I keep on adding them. If any negative charge comes, you have to subtract them. So this is what we have studied. Similarly, phasors are also like vectors only, It's just that we draw it in the form of circle. It's like a drawing. It's like a drawing. It's a diagram. Phasor diagrams are just like drawings where you just by arrows, by making the phasors in the form of arrow, you represent the vectors, the rotating vectors. And here, when we're talking about rotating vectors, it's not those vectors, electric field, force, and the vectors which you've studied. Rotating vector means a quantity which is moving in a particular direction. That is your rotating vector. So here, current is also a rotating vector. Current is also a phasor. If your current is a phasor, then your electric field is a phasor, right? Current is a phasor, electric field is a phasor. So understand this portion very well. Pay all your attention here. AC requires your attention and practice. Otherwise, this chapter is not tough. You will understand it. It will be easy for you to deal with. But if you're not able to understand the basics of this chapter, like phasors, phasor diagrams, in which case the current leads, in which case the current lags, and what is the formula of IRMS and how it relates with the peak value, what is the peak value, how do you relate angular frequency with the linear frequency, you will not be able to solve this chapter. And I think at every step we are solving each and every point, and I'm giving time also to this chapter. So pay attention here. We are not lagging behind in the syllabus so much that we have to quickly complete it. We'll be able to complete it. If needed, I will take your extra classes. We'll give some more time, but pay your attention properly. So when we're talking about phasor diagrams, proper angle can be shown between them. Like if I just ask you, as a layman, if I ask you, suppose Sufyan, if I ask you Sufyan and I ask you that two vectors are there, okay, current, and I am not able to understand through this sinusoidally and all. So basically what is happening? So what you can do as explain a layman person, what you can do? You can say, see, suppose this is the value of the EMF, peak value of EMF, and this is the peak value of current. So current is ahead, moving ahead of the EMF, and EMF is still at this angle from the baseline. Let's say this is the angle of the EMF, this is the angle of the current, and in between they are having certain angle, which we are representing it as phi. So isn't it easier? Now, after some time, if the values change, and sometimes I ask Sufyan again, and I say, now what is happening? So he can easily show other things. He can say within the same diagram that yes, now the current is here. Now the current is here. This is the total angle. This is the total angle. He can say this. So now it's easier. He can say this, they are making an angle of 90 degrees. So phasors are just diagram in order to help our calculation. You will see yourself how with the help of phasors, you are able to remember all the cases. You have 3 cases which you have to deal. And then after those 3 cases, you have the case of LCR. LCR circuit itself is a case. So for dealing with all these cases, you need to understand the basics of it. Okay. So this is how you deal with phasors. Now, if I have to plot it, same thing, using this phasor portion only, I'll be able to plot it. Suppose these are just random examples. Suppose I make it like this, that yes, when the EMF has just started from the origin position, the current was already at this position, like this. So that's why the graphs and the phasors are equally important in this chapter. And if you just have these two, you will remember everything. You can make short notes also for this chapter at least, and this portion which we have to deal. Write this down. Then I'll start with AC circuits having only resistor. Okay. So in this, you will see yourself phasors and phasor diagrams importance. Write it. See, AC circuit containing only resistor means only one resistor is there, and this represents the variability of the alternating current. See, we cannot properly put it with a battery and a switch because then only a certain amount of current will come, and that will be your direct current. So that's why this is showing this is AC dynamo. This is showing that this is alternating current. You've studied about it. So E is equal to E naught sine omega t. You have to remember all these derivations. It's a theoretical chapter too. So, you know, V is equal to IR. You can relate it with this. So, E is equal to IR. Let's put it like this. E is equal to E naught sine omega t. It's equal to I into R. Okay, E naught sine omega t is equal to I into R. So what exactly is I equal to? See, this I hope you know, this is from your Ohm's law. This is from your Ohm's law. So E naught sine omega t is equal to I by R. Okay. So what is current equal to I naught sine omega t divided by R, right? What is E naught by R? Class, this E naught by R is basically, see, it's like your Ohm's law. V is equal to IR. So I will be equal to V by R. So if we are saying V naught, so this is I naught. Yeah, so this is basically your I naught. If we say I naught, so what is the equation? I is equal to I naught sine omega. This is the value of the alternating current. This first one is very simple. You have to pay attention and give a little time to the lengthy derivation when we are studying the inductor and capacitor. Now, why is this one easy? Firstly, look at the equation of E naught. E naught and I naught. Look at the formula of both of these. E naught sine omega t, I naught sine omega t. Is there even any difference apart from that this is for voltage and this is for current? No. It means there is no phase difference in this. There is no phase difference. That is, both are in the same phase. So if I have to represent this in the phasor diagram, how will I represent? See, both are in the same phase with omega t with the base axis. There is no gapping and there is no angle between I and E. Look, I is moving there. E has also started from the same point. Now question is that E is a little higher. Here also E is a little greater. Then how can we say they are in the same phase? No, class. Always see the phase from the angle. Phase means how much gapping is there between I and E. So see, class, if you see here, there is no gapping. What is then this gap represent? The question is that what is this gap then representing, or what is this extra portion representing? It's just representing the magnitude. It can be there that the magnitude of E naught is greater than I naught. That's why this is higher. It could have happened that I naught is greater than E naught. But what is concerning fact here is that both are overlapping from the starting point. If they have the same magnitude, they can exactly overlap with each other. Likewise, the same thing is here also. This is just a diagram. This is just an example. When you get actual questions, you will see if E is greater than I, which has to be drawn ahead. That is the only difference. Phase is same. See, same phase. Phase means when we are talking in terms of the angle. When we are talking in terms of the angle, this is your phase. Always relate your angle with the phase. It's clear? Then only inductor, only capacitor we'll see. First, you write down this one.